So let's quickly recap what did we do last time. First of all, we created the list node class that has just two properties. One is value, and we decided it will be an integer value, but it can be anything. And the second one is list node. Basically, it's a pointer to the next node. And we have a constructor right here. Then we created the linked list class where we just said that our linked list has head and tail. Also, I mentioned tail is completely optional. Usually, sometimes you'll see just head inside this class. And then we added a bunch of functions. For example, we added the ability to print our linked list by iterating through the list and just printing the value on each step. We also know how to add the new node. We also know how to add the node to the start, so like to the head, a new head basically. And also we showed you how to delete node. Today we're going to do two more questions for a linked list, and then we'll cover one just arithmetic problem that I think is pretty popular in the interviews. Great. So let's start from the linked list problem. Let me quickly recall what is the problem number on the lead code. Okay, here it is. So number 141, the problem is called linked list cycle. And the problem is really interesting. You are given with the linked list, and you need to determine if it has a cycle inside or not. How to do that? So for example, we have a head, and that's our list right here, right? So 3, then we go with 2, and then we go with 0, and then we go with -4, and then the pointer to the next points to the existing node. Or like here, we have just 2 nodes, but it's cycle, right? Basically, a second node next points to the first one. Great. Now question is how to do that. The one idea is, let's just note every single value we see in the array, for example. And if we see the second same value, maybe it's a cycle. But that doesn't work like that, because there can be repeated values. For example, all values can be 3s. It can be 3, 3, 3, 3, but the pointer to the next one will point to existing one. So we're talking not about the value here. We're talking about the actual node that is same node as before. And that's very important difference, right? So we cannot assume if we see the value that we've seen already, we cannot assume it's a cycle. I want you to think about this couple of minutes, maybe drop some ideas. Maybe some of you know how to solve this problem, right? It's kind of popular and famous. It's called Floyd's problem. So think about this 3 minutes. Drop some ideas inside, please. Okay, not much ideas I can see in Slack, so probably let's continue. Let me show you. I'll try to draw. I'll try my best. So we have this situation. It's a head, and then it shows to some other node, it shows to some other node, it shows to some other node, it shows to some new node, it shows to some new node, it shows to some new node, and then the next one shows to the existing one. So what can we do here? Let's create 2 pointers. We can name them slow pointer and fast pointer. And then we're going to create a loop. So we're going to iterate through the linked list with the interesting idea. The slow pointer will be iterating by 1 every time. So will go by 1, this, then jump to this, then jump to this, etc. Actually, let me, 1 second. So this is slow, and let's say this is green. So slow guy will iterate like that. It will go here, and it will go here, then it will go here. And the green guy, the fast one, it's not, it's a fast iterator. It will go by 2 steps every time. So it will start from the same head, and then it will jump to here right now. And then the next one, it will jump here. And then the next one, it will jump here. And then the next one, it will jump here. And the slow one will jump here as well. So what 2 outcomes can we see? What 2 possible solutions can we see here? How to understand if there is a cycle or not? If pointers meet, there is a cycle, absolutely correct. So if there is a match right now, so this guys meet here, that's definitely cycle. What is the other possible outcome here? If they not meet, what we can see in the other case? Come on, guys, if there is no cycle, then what will be the last element? No? Remember, every linked list has an end, right? How can we understand that there is a last element of the linked list? If the next node shows to now, that's the end. So in our case, we'll either see the now or the pointers will meet. There cannot be other third case here. Cool. Let's code it. Let's code it. How can we code it? So basically, I showed you idea already, right? We'll introduce 2 pointers, fast and slow. So we'll move, we'll iterate by 1 every time. Fast will iterate by 2 every time. And then we will see what's going on. So it's a Boolean function, right? Because either they will meet or not. So has cycle. We're given with the head only. And our idea is great. So first of all, if there is nothing inside linked list, if there is, let's say, 0 element or 1 element, right? So if there is just a head there and it's now after head, then there is no cycle, obviously, because there is no linked list. So that's number 1 case we are going to check. If the head is null, basically there is no linked list, or the next element is null, means there is exactly 1 element, then we immediately can return false, because definitely there is no cycle, there is no linked list actually. And after that, we can iterate. So while, and then we are going to think about the condition later a bit. So we know the speed already, right? We are going to iterate slow by 1. So sorry, let's introduce slow and fast list nodes. So list node slow will be head, and list node fast can be head, or we checked already the next of the head. So let's even point to the next one. So head.next. Right? Now, we are going to say that slow equals slow next. So just iterate by 1. And the fast equals, sorry, fast equals fast dot next dot next. So this means let's iterate by 2, right? Our step is the next of the next. Cool, but we need to check that there is actually next dot next, because what can be the case here, there is only, let's say, 2 elements, and you're going to say dot next, and that's a null. So that's a crash. So let's check that if fast equals null, why not so? Because fast will reach the null definitely faster, right? Because it iterates by 2. Or even fast.next is null. Then we met null, means there is no cycle, because if there is a null in the end of the linked list, there is definitely no cycle. So we can return false. There is no cycle. Otherwise, so we're going to iterate before they meet, right? Before they meet means before slow does not equal to fast. That's it. They are 2 pointers, right? So they will point to the same element and they will be equal here. Cool. If they met, means if they met, there is a cycle. So we can just return true. Cool. We return true right away because they met means there is a cycle. How to test it? We can test it by, let's say, cycle test. We can test them by, let's say, so let's copy the first, second, third, fourth, fifth, and then our head is first, the next is second, the next is third, the next is fourth, and the next of the fourth will be, let's say, second, right? Means there is a cycle. So if we are going to check it with linked list.has cycle, this head, we're going to check this. Basically, Boolean has cycle. Then we can assert true has cycle, because we know there is a cycle, because here is it, we cycled it when force next equals second. So let's test it out. And it works. And then let's do the same thing with no cycle. So no cycle test. Basically, we are going to say fourth next equals fifth, and that's it. Fifth next equals now. So we are going to assert false that has cycle. And it works as well. Any questions? What is the complexity here? Basically, we will iterate as many times as the number of nodes. So it's big O from n. Time is big O from n, and memory is constant, right? Because we didn't allocate anything. We just allocated two pointers right here. That's it. Any questions? Can you drop plus or plus minus? Cool. That's a really popular and famous problem. I think there is a computer scientist, Floyd, that solved this problem. So it's Floyd's problem. Also, it's sometimes people reference to this problem as Torture and Rabbit, because basically you can name those list nodes as Torture and Rabbit, same as in a fairy tale, right? And they just run. The rabbit runs faster, and then they will either meet or reach to the end. Great. The last one for linked list, odd even linked list, really interesting problem. So we're given with a single linked list, and your goal is to group all odd nodes together, followed by even nodes. So basically, you need to rearrange the pointers in such way that if you have 1, 2, 3, 4, 5 now, then you do with 1, 3, 5, and then odd, and then even 2, 4 now. So 1, 3, 5, 2, 4 now. Here, for example, 2, 3, 6, 7, 2, 3, 6, 7, odds first, and then evens, 1, 5, 4. And congrats, that's the first medium problem we are solving. Draw a little bit. Okay, I'll draw here as well. Where is where's my pointer? Wait a second. Why cannot I draw? That's weird. It's an eraser. Okay, doesn't really matter. Okay, I can draw like that. Great, so we have had that shows to node, that shows to node, that shows to node, then shows to node. That's just a careful work with nodes, basically. That's what it is now. Now, we have a head. That's a head. And we need to chain all odds together and then all evens together. So how to do that? First of all, we have just head here, right? We need a couple more things. Let's add 3 more pointers. So first of all, we will add odd pointer. So because we don't want to lose head, we will leave head as it is. And then we're going to add odd pointer that we will work with, that we'll try to iterate by odds only. Same with even. We're going to add even head. So basically that's even head that will be a first even node whenever we are going to need it. And the second one is just an even pointer that we are going to work with as an even thing. And then let's just play around with that. So basically, what's the move here? That's an odd. Our odd next will be what? Give me an idea. What will be my odd next now? Where should I point it to? To here, to here, to here? Ah, 3, okay. But how to get that number? Odd dot next dot next, head dot next dot next. Okay, so first of all, let's try to not use head because we're going to reuse the same action in the iterator whenever we're going to be far away from head, right? So that's why we created this odd and even pointers to work with them. So we leave head as it is. So odd next next looks correct, but we have an even here, so let's use that. So if that's an even, then odd next is even next, right? So it's this guy. Now, Then obviously we can move odd to the odd next, right? As a step. And then let's do the same thing with even. So what will be my even next? Right, odd next, correct. If that's my new odd, then my even next will be odd next. And that's exact even next, odd next. And then even equals to even dot next. So that's exactly how we're going to move through this chain. And then in the very end, we're just going to say that our odd next is my even head. And that's how we're going to chain those two linked lists. Cool, right? So let me clear all my drawings. Great. So we need a new list node. So I need to return list node. And odd even list is the name of the program. So I'm getting head here. And my head is, so if the head is now, then we can stop, right? So if head is now, then we can return now right away. So there is no list node, just return now. But let's initialize our new three variables here. So list node odd equals head, right? Then list node even equals the second one, so head next. And then list node even head equals even for now. Cool. Now let's play around with our while loop. So we know the actions already, right? So we just move our odd next to our even next. So odd next equals even next. Then odd equals odd dot next, right? So we know how to move it. Odd equals to odd dot next. And same thing with even. So even next is an odd next. We discovered this in Slack already. And even equals even next. Great. So what is our condition here? When should we stop to do that? When either even or even next is now, right? Then we can stop. So if even is now or even dot next is now, then we stop. And the last thing to do is chain odd linked list to the even linked list. We can do that by odd dot next equals even head that we stored right here. And return head. Really hard to unit test, so let's just run it through lead code. It's really hard to write this test. We have a wrong answer here. What's going on? So 1, 2, 3, 4, 5, and we are returning 1, 2, 3, 4, 5. Something is wrong. if head is now oh, sorry, while even doesn't equal to now and next doesn't equal to now, right? That's a very important difference. One code. Also, we need and here. Cool, accepted finally. And congrats, success. As you can see, I solved this problem 4 years ago for the first time. Was kind of hard. 4 errors, and then accepted. Cool. Any questions? What is the memory here and time? What are the time and memory for this problem? Yes, so time is obviously big O from n because that's exactly how many times we move through it. And the memory is big O from 1. Great. I think that's enough for linked list. You can find more problems on the lead code for linked list. There are really, I don't know, 20 or 30 linked list problems because it's quite popular problem set for the interview. The last problem I would like to show you today is completely arbitrary from our topic. So it's called +1 problem, 66 on the lead code. Just to change the topic and play around with completely different ideas. Given a non-empty array of digits representing a non-negative integer, increment 1 to this integer. So basically you have an array 1, 2, 3. That's a representation of 123. So you just need to say it's 124 now, and you are outputting the array of 1 to 4. Or let's say 4,321, that's an output, 4,322. It looks pretty easy, but do not forget there can be, let's say, 9999, and that's where the problem starts, because if you're going to increment this by 1, then the result is 1,0000, right? So you need to somehow increment the number of elements and change all of them. Right? So it's not that easy. So what does it look like for you? So it looks like add to column, right? So remember how did you learn the addition in the school? You just wrote things like that on the paper, and there is a technique how to add them. So that's similar thing, because you cannot you don't know that it's 9,999. That's an array for the programming, for the computer, right? So we need to play around with it as with the array. So I'll add the new class. I'll name it +1. +1. And we can copy the template from here. LeetCode provides us with the templates, which is good. Great. So we're given with an array and we need to output an array. How to do that? Let's always draw things and see what's going on here. So 1, 2, 3, 4, 5. The easiest solution will be, let's just increment this last digit and see what happens. If it's just a 5 or whatever, then that's a result, right? We don't need to do anything. But if that's a 9, that is a problem. That is a problem. Basically, if that's, so let's start from incrementing. So digits, lengths -1, right? So the last element, plus. So plus means add 1 to it, right? That's how C++ was formed. So plus adds 1 to whatever was here, to the 5. So right now we got 1, 2, 3, 4, 6. That's an easy case, but let's assume we have 999 in the end. Then right now we have 9, 9, 10 in the end. And that's not correct, right? We cannot have a digit 10. So let's do the next logic. Let's iterate from the end. So let's iterate from the 10, the 9, 9 to 1. So let's iterate from the length of the array to the first element. And then if we see 10, then we will say it's 0, but the previous one is 10, right? For int e equals digits length -1. So from the end till it's bigger than 1, right? We are going to stop here, because if that's a 10, then we need to do completely different story. We need to increase the number of elements, right? So we're going to decrement the I, right? I minus minus. Basically decrease E by 1 every iteration. And then if digits from I is 10, then it cannot be like that. So then digits from I is 0. That's not 10, that's 0. But this guy should be 10 now. So digits from I minus 1, let's add 1. So this works for such case, because we'll get 9, 10, 0, then we'll get, then we'll get 10, 0, 0, and then we're going to have 1, 3, 0, 0, 0, which is a correct answer for that. But what if we're going to have 9, 9, 9 as the first one? So we're going to have 9, 10, 0 as a second one. Sorry, the first iteration will be 9, 9, 10 by this one, and then you're going to have 9, 10, 0, then you're going to have 10, 0, 0, and that's where we need to do something more, right? So if the first digit is 0, so if digits from 0 is 10, then we need to do more stuff. We need basically to say that array so what do we need to do? We need to say that this is not 10, this is 0, but let's just add one more 1 before it, right? So that's an answer. So we're basically have to say that in that case, if that's a 10, then nullify it to 0. Then basically we need to create a new array because we need to increase the number of elements. So our new array will be that number of digits inside. So digits.length plus 1. That's our new array. And basically array from 0 is 1. Everything else is zeros, right? So we can just do a for loop here from 1. So the first one is 1 and everybody else is 0. So we can say that I less than array.length I plus plus. Everything here is array from I is 0. That's it. So the first one is 1, all others are zeros. Then we need to return array in this case and return digits in this case. It's gonna have zeros by default. That's kinda true. We can probably check it out. Are you sure? I think Java does not guarantee it. Default array values. So I think Java does not guarantee it. I remember I've seen, maybe it was an old Java though. Need to double check with that. But good point. If that's true and it has zeros by default, then those lines are optional. Cool. Let's try to submit it. Accept it and then submit. Success. Faster than 100%. Any questions? No questions? Cool. Then thanks for complexities. Good question. So what are the complexities here? Obviously, the memory here can be the big O from n, right? Because there is a chance we'll create a new array. Because there is no way you can expand this array right here. So yeah, the memory will be, the worst case scenario will be big O from n, and the time is big O from n as well, right? That's a 1 for loop, that's a maximum second for loop. But they're sequential, not nested. So big O from n, big O from n.